Now, in this chapter, chapter number 4, we are going to discuss about the data types which are going to be used in VHD. That means in like this, think about like this. In C, what we learn is integer types, character types, float types. The similar way, VHDL also provide you some types of data, and which is much more classified and better in VHDL than the programming language C or C++ do have. Okay. Now, objective. What is the concept? It has to be have a signal, variable, constant. These are the object types of data types. That means which object we are going to use for VHDL programming. Uh, in this topic, we have a three main basic object types are signal types, variable types, and the constant type. The first is the signal type. Already we have discussed this signal type and variable type in chapter number 3, but again we will start with a fresh new look and the declaration. A signal is an object used to connect the entities together to form the model. Means it's a mean of communication of dynamic data between the entities. Now, signal declaration is start with the keyword signal. We will give the name to the signal, colon, type of signal, whether it is integer or whether it is something left different, and the initial value, if there is any initial value of that signal, semicolon. Okay, this is the declaration type, look of this signal. An example of the signal declaration is given in the following example. Library use IEEE, use of IEEE standard logic 1164.all package. Now here we have defined the package, okay, and by the name SI this one, okay, SIGDEC1 is now type bus type is array of 0 to 7 of standard logic. Signal, as we have defined, the signal will start with the keyword signal. Okay, name of signal, let it be VCC. Type standard logic. Initial value should be equal to 1, logically 1. Again, second signals they have declared in this type. Signal with start with the keyword signal. Ground, given the name to the signal. It's a type of standard logic and has initialized with the value of 0, logically 0. Then again, they have defined the function. Function having a name, keyword as a function, start with the keyword function, having a name of magic function, having integer a in a bus type. Now bus type, you already defined this type. You can see bus type is an array 0 to 7 of a standard logic. Return the bus type. जो return value होगी वो भी bus type में होंगी. That means it will be also an array of 0 to 7. End of the logic SIGDEC1, SIGDEC1. We are writing our program now. The package has been completed. Now the program has been written. Use work SIDIC package and all. Library IEEE use library IEEE standard logic 1164 all. Entity started with the keyword entity. Board design is the name of entity. Is having a port. Now port data in is the name. In bus type. Now bus type, we define bus type in a package. The bus type is what? Is an array of 0 to 7 of standard logic. That means data in is also 0 to 7 array of 0 to 7 in a standard logic. Data out is the output in bus type also. Bus type again the same. Bus type is an array 0 to 7 of standard logic. That means data out is also 0 to 7, that is 8-bit line. Here in entity, we define again a signal with the keyword signal. Given the name to the signal is system clock, SYS clock, having a standard logic type, and assign the initial value as a 1. End of entity architecture, it start with the keyword architecture. We will give the name to the architecture as a data flow of entity board designing. This entity we define beforehand, board designing, which we are going to use. Okay, board designing is, okay, we are going to declare in a declaration space of architecture. Again, we are declaring a signal, start with the keyword signal. Int bus, given the name to the signal as a int bus, it is a bus type. We have defined this bus type means in a package, it's array of 0 to 7, array of 0 to 7 of standard logic. Okay, that means int bus is also 8-bit bus. Constant, keyword constant. Why we use the constant? Very simple. When we are not ready to change the value of some variable throughout the programs, we can define it in a constant. That is very much appreciated work. And you can say programmer has it's charm to write, and a constant give the way. If you change the value of constant for some reason, it's very easy. Once you change that is an initialized way, when it is initialized, the everywhere it constant value get changes. You don't need to write again and again the constant value. Here we are using a constant by the name of disconnected. It's a bus type. We define bus type means what in a package. Okay, and giving the initial value as undefined, undefined, undefined. Now it's a bus type, that means it has a 8-bit 0 to 7 array, that means 8-bit. We will calculate whether we have given the value as a 8, 1, 2, 3, 4, 5, 6, 7 and 8. We have given 8 undefined state to the disconnect name bus. Now this total is a statement, since it's a very long statement written in a 2 line, but it's a single statement. Architecture begin with the begin name. We are going to write sequential line for the architectural sequential statement, signal concurrent statements, which we call, okay, int bus is equal to data in bus. Okay, data in also a bus type when system clock is 1 as input bus is also 8-bit bus. Out data is equal to magic function we have defined into the package when system is clock 0, else disconnect is a constant value which we define in an architecture declaration area. Now system clock assign the signal not of the system, that before whatever it is, it's opposite to that, it's a complement of that clock beforehand. After the 50 nanoseconds, end of architecture data flow. Okay, data flow is the architecture name which ended over here. A signal VCC and grounds are declared in a package. Because these signal are declared in a package, they are referred, they can be referenced to by many other entities, and they are global signals. Okay, once you define that signals into the package, it's a globally available to any entity, to anywhere within that program, within that writing. Okay, now again we will go further. We can use those signals by writing use work dot package name sign deck1 dot vcc or dot ground, or we can write all. That means both are going to include that. The signals go global to the entity. These signals are global to the entity. The next topic is signal global to the entity. Okay. Inside the entity declaration section and board design which we have done, we have a signal called system clock. Now this is signal that can be referred as a board design, entity board design, and any architecture of entity board design. For example, there is only one architecture right now, that is data flow. Data flow is also using the clock signal, system clock. But if there might be another architecture available in that entity, we can use that system clock as their signal. Now, local signal. This type is called global variable. What is the local variable then? In architecture, again, we have defined a signal. Okay. In architecture, we define the int signal. This is the local signal. It is only available in architecture. Whereas system clock signal in entity is a global signal. Okay, that is the main difference between the global signal and the local signals. The signal int bus is of the type data bus, a type defined in a package DAC, SIG DAC. Okay, this bus type is defined in a SIG DAC, and it's a local signal for the architecture variable. Now, somewhere we have defined or we have used variable, which is much more appreciable work, since we know that the signal will assign the value after once completing the above total example. Now, variable definition or variable declaration look like this. Variable is the keyword. Name the variable with some name, variable type, and the initial value. Whatever the value you are going to assign the variable. If you are not assigning, okay, it will be work in the next way. In the program, you can assign any value to the variable. Only you can't assign any value to the constant. Okay. Now, library IEEE use library standard logic 1164. The all entity and 5 is port A B C D E is a input standard logic. Q is the output standard logic. End of entity 5 architecture by the name of AND5 for the entity of the entity 5 is begin. Process the sensitive list are A B C D E. Variable, start with the keyword variable, give the name to the variable as a state, is a type of standard logic. Variable, again, give the name to the variable as a delay, and it's a time type. It's not a standard type. That means whatever we are writing in a delay, it's going to be a time for delay. Okay. Begin, state. State is a variable state. Assign the value. Now, assign the value to the variable is colon equal to A logically and with B logically and with C logically and with D logically and with E. If state is 1, then if loop delay is equal to 4.5 nanosecond. Delay is assigned as a time variable. So 4.5 is a nanosecond time for delay. If it is 0, 3 nanosecond, else it is 4 nanosecond. End of if loop. Output Q is equal to this variable state after the delay. Okay. Now delay, if the state is 1 or 0 or any other value, depend upon that the delay will get the value. This variable delay is given by this if loop. End of process, end of architecture 5 and 5. Why we are using variable? Because the variable assign instantly the value, where signal does not assign the instantly value. It need to go through once in a program, and when it start the next time, the signal have assigned the previous value. Constant, as I have already introduced you, the constant object assign the specific value of the type. Constant gives the designer ability to have a better documental models and a model that is easy to update. For example, if a model required a fixed value in a number of instances, a constant should be used. By using a constant, designer can change the value of a constant and recompile it, and all the instant the constant value updated to reflect the new value of the constant. That means if you are using a constant, it gives better outlook from the designer. For example, constant start with the keyword constant. Give the name to the constant like pi. It's a type of constant. It's a real type having an initial value 3.1414. Declaration look like same. Keyword constant, constant name, constant type, and the initial value of that constant. One example we will see for the constant. No, it's not given. Okay. Constant has the same scoping rule as a signal. A constant declared in a package can be a global. If you are declaring a constant in a package declaration, it will be global. If the package is used in number of entity, it, it is available in every entity. Okay. A constant in an entity declaration can be referred as to any architecture of that entity. A constant in an architecture can be used as a statement inside the architecture. All other architecture will not refer that constant. Okay, we will stop and data type will be start in the next recording.